displacement from velocity time graph. We are given the velocity versus time graph of an object. The direction to the north was taken as positive. Can we determine the displacement of the object from this graph? Let us see how. We know that velocity is the displacement divided by the time taken. V equals delta x over delta t. Rearranging the terms, we get delta x equals v times delta t. Stating in words, the displacement is the velocity multiplied by the time interval. If we observe the graph carefully, the shaded region is the area of a rectangle. Its area is given by the length times the breadth. This gives the displacement of the object between t equals 0 second and t equals 4 second. We can also understand this as follows. The object has uniform velocity of 10 meters per second. In 1 second, it will be displaced by 10 meter. Therefore, it will be displaced by 40 meter in 4 seconds. Now, consider the graph of the same object for a total time duration of 10 seconds. The displacement from t equals 0 second to t equals 4 second is still the same. From t equals 4 seconds to t equals 10 seconds, the object is travelling with a velocity of minus 8 meter per second. That is the negative direction. It is travelling south. The displacement during this time interval can be known by finding the area between the velocity time graph and the horizontal axis. This is another rectangle. The area is given by its length times breadth. This equals negative 8 times 6, equals minus 48 meters. Note that the velocity is negative, and we need to consider the signs. The negative sign before 48 does not mean that the area is negative, for area can never be negative. It means that the area is below the horizontal axis. In other words, the displacement is negative. We can find the total displacement from t equals 0 seconds to t equals 10 seconds by adding the two displacements. Total displacement equals area 1 plus area 2, equals 40 meters plus minus 48 meter, equals minus 8 meter. Therefore, we can conclude that the object was displaced by 8 meters towards the south at the end of 10 seconds. The graph of position versus time can be drawn. We need to choose the origin. Let the original position of the object at t equals 0 second be the origin. Since it is motion under uniform velocity between t equals 0 second and t equals 4 second, the graph will be a straight line with a slope. We know the position at t equals 4 seconds is plus 40 meter. The object is in motion under uniform velocity between t equals 4 seconds and t equals 10 seconds. So, the portion of the graph for this time interval will be another straight line with a slope. We know the position at t equals 10 seconds. It is minus 8 meter. This gives the displacement of the object between t equals 0 second and t equals 10 seconds.
Starting to feel it? Now go master it with Maski.